Welcome to Easy Math TV. This is another statistics video in our series on StatCrunch and doing inference. So we're in the final chapter here, chapter 8, where we're going to be doing hypothesis testing. And this video, we're going to do a hypothesis test of a mean. And I would like to go over basically all of the questions that we should be asking ourselves when we see a problem and what are the important parts of this kind of a question. So in front of us is a one of our homework problems, and this is one that we get to go through the entire process. So I want to just do an overview of what the process of hypothesis testing is and what are some important things that we should write down as we are working a problem. Okay, so let's read the question first here in front of us. We have the work week for adults in the US that work full time is normally distributed with a mean of 47 hours. A newly hired engineer at a startup company believes that employees at startup companies work more on average than most working adults in the US. She asks 12 engineering friends at startups for the lengths in hours of their work week. Their responses are below, so we have a table here with their responses. And we want to test the claim. So when you see that phrase, test the claim, you know you are doing a hypothesis test. Test the claim using a zero point 0.05 level of significance. Okay, we've talked about that before. And then we're going to be giving our answer to at least 4 decimal places. So that has to do with providing a thing called a p-value. So we're going to talk about that in a moment. Um, but let's start with just understanding what the problem is all about. I have some notes that I jotted down over here. So look at the first sentence. The first sentence says the work week for adults in the US that work full time is normally distributed with a mean of 47 hours. So what we have there is the phrase adults in the US, which is really referring to all adults in the US. So there's a clue. The clue there is that we're dealing with a population, okay? um, all adults in the US. So it's the population mean that we're being given in that sentence, the 47 there. So I'm going to literally write down on a piece of paper using the Greek letter mu, mu equals 47. All right. That's what's being told to me in the first sentence. Then I'm also going to want to write down these next two um, things. We want to know what the population of interest is, and we want to know what the parameter of interest is. In other words, what is it that we're measuring about that population? So in this case, the population of interest is adults in the US that work full time. All right. And we're also interested in sort of a subgroup of um, workers at startup companies, but essentially the population is adults in the US that work full time. And then the parameter of interest, in other words, what are we measuring? We are measuring the mean weekly working hours of US workers. All right. So the mean is what we're testing here. Um, Next, the second sentence gives us our claim because um, it doesn't say claim, but we have a statement of belief. So when you have a statement of belief, that is a claim. So we have a newly hired engineer believes that employees at startup companies work more on average than most US workers. So that belief is the claim. And that word more is going to be important because that is going to help determine what our two hypotheses are for our hypothesis testing. The word more than. So let's look at the details. The details are number one, we have a sample of 12 because apparently 12 engineering friends were asked for the lengths of hours of their work weeks. The second fact that we have is that our level of significance that's given to us in the problem. We're testing the claim using a zero point zero 0.05 level of significance. And then we also know that instead of having like a summary of our data, we actually have the data itself. All right. So those three things are going to help us set up our test, our hypothesis test, and we're going to be using StatCrunch for that. So let me move this off to the side, and I'm going to highlight our data here. Highlight it, and I'm hitting Command C to copy. If you're on a PC, you will want to hit Control C. And I'm going to go over here under var1 and I'm going to hit Command V. And if you're on a PC, you would hit Control V to paste. So there's our data. Now, to do a hypothesis test on a mean when we just have raw data and there's fewer than 30 values here. Notice the sample size is smaller than 30. We're also not sure what the original population standard deviation is. So all of that together means that we're going to go under the stat menu and we're going to do T stats. T stats. So this is our capital T is what we use when we're testing a mean and we have a small sample. And it's one sample with data. So I'm going to select my column. My column is var1. Make sure I have that. And then we're interested in a hypothesis test now. So this part is important. We have a null hypothesis, which is H subscript 0, and we have an alternate hypothesis, which is HA. So H0 is the null hypothesis. That is that represents the status quo, or that represents what we are testing against. So if we pull this thing back again, what are we testing against? We're testing against the population mean of mu equals 47. See that? So like that is kind of the status quo. That is what the average number of hours per week that all adults in the US, if we just take them all together and we just calculate an average of their work week, it's 47. Okay. So when you have that thing that you are testing against, that is your null hypothesis value. All right. So the 47 is going to go in place of the 0 here. Now, the alternate hypothesis is sometimes, very often, that's your claim. So whatever the claim is going to give you a clue about the alternate hypothesis. And if you remember, that was the engineer was believing that employees at startups work more on average. So more means greater than, okay? So the alternate hypothesis is greater than 47. So those two numbers are going to be the same, but one of them is the statement of equals, and the other one is always going to be a choice between not equals, less than, or greater than, and in this case, it is definitely greater than. Now, if our significance level was not 0.05, we could update that value with a different value, a different significance level here. Um, and if we were interested in any of these other plots, if the question asked us for anything else about normal, like is the data from a normal population or something like that, we could actually include some of these other plots. But we're just going to go ahead and perform the hypothesis test. So I'm going to hit compute. So we now have some information that we can use to answer some questions about this situation. And all of these values here are part of that decision that we're going to be making as to whether the claim is true or not. So actually, I'm going to pull oh, I can't pull this off to the side. Can I pop it out? No. All right, let's just leave it there. We're just going to keep going back and forth, okay? So, so pay attention to the first two statements here. These are our null and our alternate hypotheses because those are what we need to provide first. So H0 is it's a statement about it's not a statement about p hat or x bar or anything. It's a statement about the true mean. So that's mu and equals, and this is 47. And then the alternate hypothesis is mu is greater than 47. Okay, now let's go to part two. Based on those two hypotheses, it says find the following. So what is our test statistic? So the test statistic is used to calculate our probability um, that that the claim that the claim might have validity. Okay. So notice our test statistic here is multiple digits. I'm gonna just copy and paste it into that window, and I might as well just include out to there 3.3840, and now it's asking for the p-value. So that the p-value is the thing that we use to make our decision. Because there's a decision to be made. The p-value is 0.003, so I'm just going to, again, I'm going to copy and paste that. Okay. Now, so what we want to do is we want to compare that number to alpha. 0.003 compared to alpha. I'm going to go ahead and just sort of insert a statement here. So 0.003, now, is it less than or greater than? So does this make sense? If I put that there, notice the number of zeros that come after the decimal point. The more the zeros, the smaller the number is. So 0.003 is less than 0.05, which means that our p value is less than alpha. When that happens, we reject the status quo, which is the null hypothesis. P-value is less than alpha. We reject the null hypothesis. So correct decision is to reject the null hypothesis. And then what is our conclusion? So the summary statement or the conclusion is going to be kind of like just go back to the statement that you're testing here. We're testing a claim that was made by the engineer that employees work more than average. So if we're rejecting the null hypothesis, usually that means you're rejecting the null in favor of the alternate. So in other words, we have sufficient evidence. So like we want to be able to say that there is enough evidence to either support the claim or reject the claim. So if the claim had been that they didn't work more hours, then we would be rejecting it. But since the claim is that is the alternate hypothesis, then we do have enough evidence to support the claim. And that is a complete hypothesis test for the true mean of a population based on a sample. Like, subscribe, comment down below, share these videos with other people that you think might find them useful, and I'll see you in the next video.